All right, 7.2D is special cases of factoring. So I want to make it very, very clear that for all of these problems, you can 100% of the time use the box method or reverse distribution. It's just that for these special cases, they have patterns which would make it easier to factor if you remember and use the patterns. So we're going to talk about perfect square trinomials and difference of squares. So I'm just going to use the patterns, but remember, you could use the box method and you would end up with the same answer. So looking at the difference of squares, and we've talked about this one previously, but if we have something like x squared minus 36, where that bx term cancels out to 0x, that means we had a negative of a number and a positive, right? You have to have a pair of opposites in order for them to add together to be 0. And so for our difference of squares, we're always going to follow this same general format where we'll have our x's and then we'll add the number and subtract the number. And so in order to use this pattern, all we really have to do is figure out, right, look at the absolute value of our constant and take the square root of it. Well, the square root of 36 is 6 times 6. So that tells us that if we had x plus 6 and x minus 6, that would multiply together to be x squared minus 36. And really fast we can check this just so you can see how this is working out, right? And again, you could have used your box method for this, but it's just faster once you recognize the pattern. X times x would be x squared, x times negative 6 would be negative 6x, 6 times x would be 6x, 6 times negative 6 would be negative 36. Everything from my box is x squared plus 6x minus 6x minus 36. Well, 6x minus 6x, that's just our 0. We have x squared minus 36. So again, this is why the pattern works. This is how the pattern works. But once you recognize the pattern and if you're able to use the pattern, it's just faster. It's a faster way of factoring it if you can recognize that pattern. Looking at 3x minus 12, remember for these problems you always want to start off by looking for your greatest common factor. And so I know that 3 goes into 3 and into 12, which means we really want to factor x squared minus 4. Well, we're missing that middle term, and I know that 4 is a perfect square. So if we have x plus 2 times x minus 2, that would be our difference of squares. Remember to add that greatest common factor as part of your final answer. So again, we're just kind of following the same general format. Just a side note that x plus a times x minus a, you could write x minus a times x plus a. The order doesn't really matter for any of these binomials. This is the last difference of squared ones. Looking at it, we do have a greatest common factor. We have 4y cubed minus y. Well, they both have y's, so we could factor that out, which would really leave us with 4y squared minus 1. Well, for this one, it's a little bit different because we have that leading coefficient of 4, but 4 is a perfect square, so this is going to work out for us anyway. And 1 is a perfect square because 1 times 1 is just 1. So if we're looking at this, we'd have the factors. 2 times y would be our first factor, and then we'd have a negative 1 and a positive 1. And then don't forget your greatest common factor of y. And so again, this is just our pattern. This is the pattern of the difference of squares. Anytime it's a difference of squares, so anytime you're missing that bx term, this is the pattern you can use. You don't have to. You could use the box method to solve these, but these patterns are just something we want you to see. We want you to start looking for those kind of shortcuts or those easier ways to, or faster, I should say faster or more efficient ways to solve these problems. The other perfect square, the other special case we have is perfect square trinomials. And so for perfect square trinomials, remember perfect square is when you have something times itself. So that means we basically have a binomial times itself. Right, whatever that may be, a binomial times itself. That gives us this perfect square trinomial. And so, when we're solving these, it's going to follow one of these two patterns, either adding some number or subtracting some number. So for these ones, again, we're going to focus on that perfect square part. So we're going to look at our constant. Right, x squared is just x times x. 81 is 9 times 9. So since this is we have those perfect squares, if we had x plus 9 squared, that would be our perfect square trinomial. If we took x plus 9 squared, we would get x squared plus 18x plus 81. Then, looking at our next problem, we have 4x squared. Well, we'd have to take 2x times 2x for that. And for 25, that would be 5 times 5. So when you're looking for perfect squares, this one's a little, you have to think a little more to recognize that pattern. But basically, if your first term and your constant, if you can find a perfect square for both of them, then you can use this pattern, and that's how you can tell. So since I had a perfect square for 4x squared and that perfect square for 25, that's how I know that it's a perfect square trinomial. Now for this one, notice that it's subtracting 20x, right? So since it's subtracting 20x, that's how I know I'm going to be subtracting or using the subtracting pattern. So if we had 2x minus 5 squared, that would be our perfect square trinomial. And you could multiply these out to double check if you were right or wrong, but this is how it works. Again, it's just another pattern. It's a little bit faster if you're able to recognize that pattern. This last one, we do have a greatest common factor. Looking at 20, 20, and 5, 5 goes into all of those. So we'd really have 4x squared plus 4x plus 1. Well, 4x squared, I know that 4 is 2 times 2, and x squared is x times x. Looking at 1, I know 1 times 1 is 1. So since they're both perfect squares, I know we have that perfect square trinomial. And then since this is a positive 4x, I know I'm using that positive pattern. So that first term would be a 2x, and we'd be adding 1, and then we can't forget our greatest common factor, so our final answer would be 5 times 2x plus 1 squared. And those are our two patterns, our perfect square trinomials and our difference of squares. Now, if you recognize the pattern, that's great, that's amazing, go ahead and use it. If you don't recognize the pattern, use the box method, right? Use the box method. It'll just take maybe about